at x equals 0. Now, these two values equal each other, which is good, but it has to be all three. Like, this is an all or nothing thing, okay? It can't be, oh, these two equal each other, so I'm good. It's all or nothing. Either all three equal each other, or there's a discontinuity, all right? We have one more down here. This is another rational function. So we know that there's a potential discontinuity at x equals -3. And we know that this could either be a whole, so it's removable, or it could be an asymptote, which means it's infinite. We need to kind of figure out which. So if we want, we can take that function and we can actually simplify it algebraically. So f of x equals, don't lose that negative sign in the front. We can factor that as x minus 4, x plus 3 over x plus 3. And we can actually see that those x plus 3's cancel each other. So we're just left with negative x minus 4. But by canceling that out, we did actually decide then, oh, all right, we're thinking it's this potential for a removable discontinuity. But we still need to check, okay? We're going to check the limit as x approaches -3 from the left. The limit as x approaches -3 from the right. And then we're going to check the function value at -3. So again, we want all three of these to equal each other in order to say that there's not a discontinuity. Okay? So approaching -3 from the left and the right, I can actually use my simplified version over here and just evaluate that limit. So if I plug a -3 in there, -3 minus 4 is -7, but there's that negative on the outside, so it's a +7. And I can do the same thing for x approaching -3 from the right. Plug that into my function, my simplified function, and I get 7. But when I plug in f of -3, this actually has to get plugged back into my very original function. And we know that we can't do that. We would actually get a 0 on the bottom, which means this function value doesn't exist. So because the left limit, the right limit, and the function value don't equal each other, we're actually going to say then that there's a discontinuity at x equals -3. All right, that's the big idea. We're going to do tons of practice in class when I see you guys in a couple of days. All right, if you had any questions, shoot me an email or come and see me during office hours. All right, bye.